Hello everyone. Welcome to this session number 7 as part of the training program on Introduction to Python Programming and its applications in water resources sector. In the first 6 sessions we have seen installation of Python along with Anaconda distribution. We have seen the utility of Jupyter notebooks, and then we have seen the basics of Python, namely the fundamental data types, data structures, control flow, file and error handling in Python. We have also seen the concept of object-oriented programming and how it is implemented in Python. In today's session, we will be walking with Pandas. The entire session will be on Pandas, which is a Python package meant for data analysis and data manipulation. Uh, the data which is in tabular form. Um, it is a very powerful and flexible package, which is also open source. And if you remember it well, we haven't installed it using Conda installer tool, but it comes by default along with the Anaconda distribution. Therefore, you can find Pandas package installed not only in the environment created by us, that is Python WRM, but also in the base environment, default root environment, you will find Pandas package installed. So let us start working with Pandas. We will start with this question, why Pandas? Why Pandas has evolved as a most sought out data analysis and manipulation tool just in a matter of 1 decade or so after its launch. Now, we have said that Pandas is a fast, powerful, flexible, and easy to use open source data analysis and manipulation tool, uh, which is built on the top of Python programming language. Now, Pandas is very fast because it is dependent upon NumPy module of Python. Its dependencies include NumPy, which stands for numerical Python. We will see about something about NumPy when it comes to raster analysis afterwards. So, in NumPy allows an efficient way of storing the data in the form of arrays, and then it is known for faster numerical computation. Um, and then Pandas is flexible and easy to use. We will see that Pandas comes with a set of functions defined within it, which are used, which are very convenient to work with tabular data for filtering the data and for presenting the results in data in the form of information. Um, and it is also an open source data analysis and manipulation tool. Because it is open source, it comes with the advantage of having a committed user and community support who keep working to make it a better package. So its performance keep on improving with more functionalities being added to it. Uh, then Pandas make working with relational or labeled data both easy and intuitive. Now, the tabular data, which is the fundamental data structure, which where we store the data in the form of in the form of tables. It can be single table data or multiple table data, which are multi-table data, which where we have which are related with by some key columns. So, because it is so fundamental and we use it daily, the tabular data, especially now in the case of water sector, we have to deal with lot of data which is presented in the form of tables. So, Pandas will be very useful. And it has become popular for that reason, and that it provides many easy tools for handling the tabular data. Then Pandas provides two primary data structures, series which is one dimensional and data frame which is two dimensional. You can see that the data frame is similar to a spreadsheet where the data is represented in the form of rows and columns. Now each column represents one variable, and the data contained within this column belongs to a particular data type. Like this column may be containing data type of integers, this column may be containing data type of floats, and this column may be containing data type of strings. Say it can be the name of a station, it it can be the gauge value or discharge value, which will be floats, and it can be the information. This column could be about information on when the station was started, year of establishment. Therefore, the data type will be of integers. Then across, however, if you so in columns we have data is of same type. In rows, the data is of mixed type. So it is very much similar to the spreadsheets, Excel spreadsheets. However, it is a programmable spreadsheet where we have many additional functionalities for handling the data, which we will see. Now, each column in the data frame is a series. We will see that data frame is nothing but a collection of one-dimensional series, which is both series and data frame are the primary data structures in Pandas. Data frame is nothing but collection of series, and each column of the data frame is a series. Further exploring the question why pandas, these are some of the major features of pandas. Pandas provides for easy handling of missing data, and then size mutability. It is the data structure is mutable. You can easily add new columns, and you can delete the columns. Then it allows for automatic data alignment. The group by functionality in pandas, it allows for aggregating and transforming data. That any differently indexed data in other data Python data structures, it can be easily converted into data frame objects. Then it has intelligent label-based slicing and subsetting of large data sets, merging and joining of data sets, flexible reshaping and pivoting of data sets, hierarchical labeling of axes, and it has robust input-output tools, which allows for loading data from various formats. It supports reading data and writing data to many formats like CSV, JS, ON, HTML, MS Excel, SQL, then HDF. To conclude in a nutshell, um, uh, we can why Pandas has evolved as an ideal tool. For data scientists, working with data typically involves multiple stages, three stages. Number one, data cleaning. Number two, data analysis, data modeling. And then number three, organizing the data and the results in the form of which is suitable for plotting a tabular display, that is, we can say data visualization. So data cleaning, data analysis, data visualization, at every stage Pandas provides tools for all these tasks, so that's why it has become very popular. Now let us start working in the Jupyter notebook. We will start with by creating a new data frame or series, which are the the primary data structures provided by Pandas. Now from now on we will be using Anaconda Navigator to launch the Jupyter notebook. You can launch Anaconda Navigator from the start menu by typing Anaconda Navigator and then clicking on the shortcut. It will take some time for initialization, and you will get the guided user interface of Anaconda Navigator. Now make it a practice from now on to change the environment whenever you are initiating any notebook. So we have the base environment, and which also has Jupyter notebook application, as well as Pandas also is installed in the base environment along with Anaconda distribution, whereas some other third-party packages like GeoPandas, etc., they are not present in base environment. You can work even in base environment, there is no harm. However, make it a practice to change the environment every time you activate the environment. So these are the applications which are available in this environment. Another way of doing it is you go to Environments tab and then click on Python WRM. This symbol, a green symbol, will indicate which is the activated environment, and you can see the installed packages where you can find pandas. Yeah, Pandas is an installed package which is high performance, easy to use data structures and data analysis tools. You will find the same in even in base environment also. So you launch the Jupyter notebook. In case if you are not finding the icon, you can scroll down and see and check. And in case if you don't you can just for you can check whether the pandas is installed along with Jupyter notebook in the python-wrm environment, just in case you have missed installing Jupyter lab in the first session. Pandas will automatically be installed. So I'm launching the Jupyter notebook from Anaconda Navigator in this environment, python-wrm environment. It will point out to my home directory where Anaconda 3 folder is installed, and I am saving all the notebooks in the subfolder notebooks in Python WRM folder. Now I will create a new Jupyter notebook, and I will rename and save it. So now we have to first Pandas is a third-party package. We have to install. We have to import Pandas into our Jupyter notebook. Now we are using the terms modules, packages, and library interchangeably. They all mean the same thing actually, but it depends upon the scale, and there are some standard generally what we mean by library is Python has its standard library, and it also has an external library where users have developed third-party packages based on Python and they are part of external library, all third-party packages. Whereas standard library of Python has its own modules, like we have seen math module, math module. And just to repeat, I can make use of one method within math. I can try printing the square root of 16 using sqrt method, which is available in math module, but it will throw a name error because the math module is not yet imported into our notebook. So into our current working environment. So I have to first type import math, which will be done instantaneously, and then I can make use of any function or any constant defined in this math module with in this format the name of the module, not only math module but any module which is part of the Python standard library. I can do this module name dot the function name, say sqrt 16, so it gives us the result. So another way of importing module is you can import it by renaming. Now generally third-party packages like pandas, they are imported as in the short form. Conventionally pandas is imported as PD. PD stands for pandas. Say I am trying to import pandas as PD. So it will take some time, but and then if you are importing pandas from the external, because pandas is in external library, and along with many functionalities and many functions, it is a big package. So for the first time it will take some time, like 20-30 seconds. Then once it is completed, you will find the star replaced by the number. So now the pandas is also installed, imported into our notebook. Um, so I was talking about modules, packages, and libraries. Python has the standard library and external library, and the standard library has modules. External library has packages, which are nothing but modules only. Packages and modules are the same, but generally we use the word packages for external modules, and inbuilt the modules within the standard library, we use the word modules. So every module has its own functions, definition of functions and constants, etc. Like math has the constant dot pi and other many mathematical functions. Um, we can import the modules directly by calling the module name, or as renaming the module, or we can even import a specific function from any module. So if you have a big package where there are only one or two useful functions, um, for the sake of illustration, there is no need to import math a square root, because we can import math module at one go. But if you want any specific function in any third party package, you can import in this way: from math import sqrt. Now with this statement we are importing a specific function or method from a module math, and if we do that, we can directly operate the method without this format of math.sqrt. I will pass on 4. So you can directly make use of the function methods. So these are the ways where you can import external modules or packages. Import by renaming, import functions, specific functions from modules or whole module, and then if there is a submodule of a module that can also be imported, like module dot submodule, import module dot submodule as something by renaming it. For example, import matplotlib, which is an library for data visualization, where there is a submodule pyplot. Module dot submodule you can import as short form plt. This is the usual convention. So now as I am doing it for the first time, it has taken some time. So this is how you import your modules into the notebook. Now let us start working with pandas. You will try creating a data frame. Creation of data frame or series from scratch. Let us try to create a one-dimensional series from scratch. I want to create a dam register as a data frame, where information of the dam, name of the dam, name of the river, name of the state where it is located, year of completion of the dam, and length of the dam, and height of the dam. I want to input all the data and use it for data visualization analysis purpose. So we will, for simplicity purpose, let us take a finite number, 5, 6 number of dams, and then try to define a data frame, making use of the data associated, and we call it data dam register. Now I am trying to create a series from scratch. Series is one dimension. Only one particular column of the data frame is the series. You can define data frame as in one go from scratch, or you can define many series columns and then you collect them and create a data frame. So I have this PD stands for pandas dot series. It is a method for creation of the series, and then you pass simply within parentheses a list of values. I'm passing the names of the dam, so they will be strings. Bakra, Almaty, Indira Sagar. Let us take 6 dams. Hirakud, Mettur, Tehri. And then you can give the name of this series, say dams. So what we are doing is we are trying to create a Pandas series by using the function pd.series, and I am passing a list of names of the dams, and I am also passing the label dams, and let us try to run this. So if you check the type of dams, a pandas series object has been created. So this represents the type of pandas series object. Let us try to print dams. So you can see that a series has been created. Series is also a data frame. It is a subset of the data frame of size having only one column. There is one column with the names of the dam names which we have passed on, and then there is an automatic indexing has starting from 0, just as in case of data built-in data structures of Python. The indexing starts from 0. So for 6 dams, the index goes from in the same order from 0 to 5, and the name is dams, and the data type is object. Now strings, instead of strings, it is displaying object. Actually, in pandas, in data frame, the strings are stored as object arrays. We'll see what is meant by array when we have a look at a NumPy module afterwards. So you just remember that you can define a series, that is one-dimensional data structure in pandas from scratch using this way by using the function pd, which we have imported. Import pandas as pd, then dot the function series, and then within parentheses we are passing the list of values as well as the label which is displayed here. So in this way you can create a series. So let us create more series, and then let us try to collect them together into a data frame. Now I want to Now the I want to create a series. I will quickly do this. So I have to follow the same order of where the dams are located. Sutlej, Krishna, Narmada, Mahanadi, Kaveri, Bhagirathi. So I am passing the list of values to be stored in the series, and I am also providing a label. Name is equal to river. You can print this series which has been created again with the indexing starting from 0 and the order in the same order which we have passed the values. Again, the data type is object. As I said, strings are stored as object arrays, and the name of the series is river. So I will quickly create remaining series. State So I have created another series, Panda series state. Then year of completion, the data type will be of integers. You can keep the data ready with just few entries for illustration purpose only. This is tedious way of creation of data frame or series, but you need not do this when you have CSV file with all the data, Excel file. And we will also try to in the next step we will do the same thing. We will try to read a big CSV file using the inbuilt functions in Pandas. we had series containing data type integer, and let us print it and see what it prints. Year of completion. So as you can see, the data type is int 64. So every series pandas series contains uh, values belonging to the same data, values of the same data type. Let us have float data type also. uh, Height of dam. I am creating another series. So I have this data of the height in meters. Bhakra in the same, we have to go in the same order. I am trying to take real values. So it is a float 225.5, Almaty 49.3, Indira Sagar 91.4, Hirakud 60.9. I have taken data in a hurry, so there may be some mistakes, doesn't matter. Mittur 70.4 and Tehri 260.5 meters, and then I will pass the name of the label also. Height. So let us have a look at this series. So as you can see, the data type is float 64. So what we have done is we have created four series pandas series, which is a one-dimensional data structure. Dams, river, in fact 5 series we have created: state, year of completion, and then height of dam. Now let us try to collect these series and make a data frame out of it. Now a pandas data frame is similar to a spreadsheet, and in terms of data structure, it is like a dictionary of lists, with dictionary keys being the column headers and values being the columns. So we have seen that in a data frame every column is a series. So we can put these columns together into a data frame. We can say the name of the data frame dam register, and then pd dot. Again, you can use tab completion to see what are the methods which are available in pandas. So for creation of data frame, just to be sure that you are not typing any letter in uppercase, generally people tend to make mistakes while typing. So you can select it from the inbuilt help options which are available. So pd.data frame, now within parenthesis it is a method. Now what to pass? We have to pass a dictionary of series. Let us first create a dictionary of series. So what I have created one empty data frame. You can check the type and you can try to print it also. Dam register, which is a data frame object. So in case of series, you have seen it is pandas.core.series.series. whereas in here it is pandas.core.frame.data frame, the type of the data frame. You can print it. It is an empty data frame. Now let us try to have dictionary. I will create a dictionary with the labels of the columns or column labels as keys. So in data frames, in series, if you have seen, there is indexing of rows. Rows are labeled, but columns are not labeled, though we have given the names for each series. So here you can specifically mention the column headers, which you want to be displayed in data frame. The key is dams, and you have to pass the series, which is dams, small d, comma. Then the next key is river, and you have to pass the series river, small capital. Next key is year. Let us pass state, and the name of the series is Pandas series is state. Then year, year of completion, height in meters, the name of the series is height of dam. I hope we have got all the names correct. So we have we are defining a dictionary dict. Dict is a keyword. So I have defined a dictionary. You can check by printing it. So this dictionary, after each key, it is printing the series. So river key, you have the series of rivers which we have defined here. So there are okay. So then now we will create the data frame. The data frame has already been created, which is empty as of now. Dam register equal to pd, short form for pandas, dot tab completion, select the method data frame. This kind of naming is known as camel casing, where every word starts with the capital word and remaining in the small lower cases. Another way is using underscore separation, using underscore to separate the words. So anyway, we will pass the dictionary 1. Let us try to print our data frame. Yeah, you can see the data frame has been created, which has 5 columns: dams, rivers, state, year, year of completion, then height in meters, and the indexing is there just as in the case of series. The index starts from 0 to 5, and the column headers are those keys which we have provided in our dictionary. So we have defined a data frame. This structure is known as the data frame. So you can imagine when you have a CSV file or Excel file or any because the pandas support many file formats. When you input the data having so you can have many number of columns, and you can have long term data. You can easily create a data frame, and you can see the data, you can check the data. Now in our data frame we have only 6 dam register. We have only 6 the data regarding 6 dams only. You can check the type, which is pandas.code.frame.data frame. Now there are some inbuilt functions which can be used to check if you have a big data frame, to get some basic statistics of numerical data present within this data frame. You can use this method of, so we are not dam register dot use tab completion to see just have a look at the methods which are available with pandas. There are many methods. So this describe method, it gives the basic statistics of any numerical data present within the data frame to have a quick overview. So it will only take those columns or those only take the numerical data into consideration. It will not take dams, rivers and state into consideration, and it will print some basic statistics like count. There are 6 values under in each column. Then there is no meaning of this mean of the year. However, height mean has some meaning. Even then, average height of dams has no meaning. So it basically gives the standard some basic statistics. The useful thing is the maximum height of the dam in our collection is 260.5, which is Tehri. When you have a big collection, you can have a look at maximum value, minimum value, and minimum is 46.3, and which is the latest dam 2006. That is there are 2 dams which were commissioned, Indira Sagar and Tehri, and the oldest dam in our collection is 1934, that is Mettur Dam. So dot describe, it gives basic statistics of numerical data. Then you can print the columns in your data frame dam register using dot columns. It is not a method, it is an attribute. So attribute, you don't put parenthesis. So you can see that the columns of this data frame, dams, river, state, year, height, are printed here, and it is data type object. Again, strings are stored as object arrays. Similarly, we can have have a look at index attribute. So index attribute, it gives a special type of object where indices are stored. Index starting from 0 and ending at 6 exclusive with a step of 1. You can get there are some other attributes that provide information about your data frame, like head. It is a method. Let us try to use the help option to get information about what it does. I don't know why it is giving everything about pandas instead of giving specific information. So this head method is used to display the without, if you are not passing any parameter, it will display the first 5 values of your data frame, first 5 rows of your data frame, along with all the column values. As you can see, only 5 rows have been printed, leaving out the last row. Let us try to pass some parameter inside head. This is used for checking your data once after inputting your data into a data frame. And if you pass any parameter, it will display that many rows. If it is head, similarly you can have tail, dam register dot tail. Let me print only one last value. So only the last value, last entry is printed. So that is about head and tail methods. And then there is another method, info, which provides general information about the data frame. So it is a data frame belonging to the class pandas.core.frame.dataframe. This DAM register is a specific instance of the class, again the object-oriented programming concepts. So DAM register is a DAM object, is a pandas data frame object belonging to the class pandas.core.frame.dataframe, where range there are 6 entries, range index varying from 0 to 5, and there are 5 columns inside your data frame. Then the columns are listed along with their indices: dam, river, state, year, height. And you can also see how many of the values are, if there are any missing data, it will provide information. So you can see that no, there is no null value, means all values are there in our data frame. There is no empty cell. Then you can see the data type of each column. Object is object means string in data frame, then integer, and height is float. So whereas in series you can have a same type of the data type in a column, in data frame you can have different data types coming together. So the data types, there is one float data type, one integer data type, and 3 string data object data type. The memory usage is so much. So in this way you can create a data frame and data series from scratch, and you can have view the information, basic information about the your data frame. So in that way we can create pandas data structures, namely pandas series and pandas data frame from scratch by typing in the data, and also view information about the data frame, basic statistics, etc. In practice, however, you never do this typing of data from scratch and creating the data frame from scratch. You generally make use of files available with you to create data frame. Now, Pandas support a variety of formats like CSV, Excel, .xls, then SQL, HTML, JSON, JSON, and so many other formats. It can read data from so many formats, files of so many formats, and it can also generate files. We can write the data contained in data frame to files of various formats. We will see both now. Let us try to create make use of a CSV file which was provided to you yesterday during yesterday's session, which is the gauge discharge data of spread over I think 11 years, which is with more than 4,000 entries. Let us check. First we have to pass on the file path. We have to create the file path. Now it is a good practice when just as we are saving the uh, notebooks in a folder, we can also save all the data in a separate folder in the home directory, where I have created Python WRM folder, and in it I have a folder for notebooks as well as folder for data, and the data folder has that particular file. Now we have to create the file path. For that we can use import OS and os dot get current working directory, which will be notebooks, but we have the data not in notebooks subfolder but in the another folder of data within this Python WRM. So we can get the home directory, but there is no functions as such in OS, whereas we can make use of pathlib module. Otherwise, import pathlib, then import OS, pathlib dot path class dot home. I assign it to home, and I will print home. So this creates a path object to the home directory. Now I can create the file path by joining the file paths using / operator, home / name of the folder Python WRM, then again / name of the folder within Python WRM data, then finally the name of our file, which is gauge underscore discharge underscore data dot CSV. Let us print the file path. It has created a file path to the file. Now pandas provide functions in the format read underscore whether if it is CSV, it will be read underscore CSV. If it is Excel, if it will be read underscore Excel. So these are the functions. I'm writing a comment. Pandas provide read underscore star format functions to read data from multiple formats. So let us create a new data frame, just as we had I will call it gaze discharge data, which is pd dot, we are creating a data frame. Let us create a empty data frame to start with. Yeah, this kind of mistakes we do because to avoid such mistakes, you can use tab completion utility of Jupyter Notebook. So now gaze discharge data is a data frame object. Let us see what are the functions which are available with it, what are the methods, by typing dot and tab. We don't have the read methods here, whereas okay, actually we can use two methods to write the data to a file, but reading from the file it is done by another we use a different way. We just while defining the data frame itself, we have to we can make use use of the function. So you press tab now after PD, you check the functions which are available. Yeah, so these are various read functions, read underscore star format functions. You can read from clipboard, CSV, Excel, HDF, HTML, JSON, JSON, pickle, SAS. There are so many formats, SQL, SQL table. There are so many formats which are available for reading data into a data frame. I will be using read CSV because our file is in CSV format. Then pass the file path. And then you can pass separator, which is the delimiter. The default separator is comma in for CSV, read underscore CSV method. However, in case if in your file the delimiter is a colon or semicolon or space or tab, we can use the delimiter by using the by overwriting the default parameter sep. However, in here you don't need to give it. So let us simply try to run this, and let us try to print your data frame has been created. You can check gauge discharge data. So it is of type pandas.core.frame.data frame. A new panda data frame object has been created. You can print it and have a look at the data. Discharge underscore data. So yesterday you have seen that you have the data in the format, the columns of your data are day, then the data type, which is HZS or HHS, depending upon whether it is absolute gauge or mean sea with respect to mean sea level, then the mean gauge in meters. Like for example, if you can see HHS of this row, it is with respect to mean sea level, so it is the data type is different, otherwise it is HZS. Then you have discharge values, and then whether the discharge is by observation or computation. This NaN stands for not a number. This is no missing data, or so we will see how to deal with missing data afterwards. So the data frame has 4017 rows indexed from 0 to 4016. Now you will have the first 5 rows and last few rows are getting printed, and the remaining data frame has been created just in a matter of by just running this cell. We can check the basic information about this data frame, but before going to that, let us see how, in case you have a different kind of format, you can have a look at help options, read CSV. Yeah, the help on function read CSV in module. It is used for reading a comma separated values file into data frame, where you have to the parameters which need to be passed are file path. Then there are so many parameters. Then sep, which is the delimiter, which is the string which we have to by default the value is default parameter value is comma within the strings. In case your format is has having another delimiter, you have to override that parameter. Similarly, there are many other parameters. Of them, one useful parameter is skip rows. Yeah. Sometimes what happens is you will be having in your file some description of the data in the initial rows, what the data is about. So if you there is no point in trying to get it read into your data frame. So you can skip so many rows by passing the parameter skip rows. Like skip rows is if you want to skip initial 5 rows where the description of the data is there in your CSV file or Excel file, you can pass on the parameter skip rows is equal to 8 to this function. Skip rows is 5, so how many number of lines you want to skip, you can do that. So that is one useful parameter. So you can get help in this way. Similarly, you can have a look at help pd stands for pandas here, read Excel. So similarly, if you have an Excel file, you can do the same thing. You can read the file, the data contained. It supports .xls, .xlsx, .xlsm. All these formats are supported file extensions. It will read the file, read from a local file system, or you can even read from URL. And it supports an option to read a single sheet or list of sheets. So if your Excel file has one sheet or multiple sheets, you can read them. So accordingly, you have to change the corresponding parameters. Like you can pass on the sheet name. In case you are reading the data from Excel, you can pass on the sheet name, which will be a string or integer or anything. Strings are used for sheet names. Integers are used for zero indexed sheet positions. Okay. So similarly, other options like skip rows will also be there. In this case also, we want to skip number of lines at the start of the file. So this way you can have help options. You can have a documentation. There is you can read the document and then you can make use of the function. So in our case, the default value sep is comma, so I was only passing the file path. Because my file has only the header, column headers as the first row, and without any description. I need not pass even skip rows parameter, and by default it takes the first row as the column headers, the CSV file. So it has nicely created the column headers by reading the first row, and from the second row onwards the actual data is there and it has read the data. And you can have a look at you can have a basic check of your data using some functions, as we have seen earlier about head function, then info function. We can also do that here. So let us see, let us check the shape of the data frame. Now, to avoid writing again and again, we are giving descriptive data just for clarity, and it is a better practice. If you are dealing with big data, you should it should provide, the name should provide the context. Let us check some attributes of this data frame. Shape is an attribute. Before shape, let us see the inbuilt function of Python. Length is also a valid function here. Yes, it prints the number of rows. 4017 rows are there in this data frame. Then check the some parameters dot shape. Now the distinction between method and parameter is, method is a function which is followed by parenthesis. Because it is an attribute, we will not write any parenthesis. So it will give the number of rows and number of columns, the shape of the data frame. As you can see, our data frame has 4017 rows, and number of columns is 5, including not including the index is separate, which is consecutive integers. There are 5 columns, 5 columns in our data frame. So it gives the shape of your data. Then quickly we can check the head rows and tail rows. Anyway, they are printed here, but still we can check first 10 rows of the data frame, index starting from 0 to 9, and you can check the last 10 rows of the data frame up to 4016. There are few NaN not a number values. We will see that. Then you can there are some other attributes like dot data types. So it will print the names of the column. Day is an string, that is object data type. Data type again string. Mean gauge is a float. Discharge is a float data type, and observed or computed, it is again a string. Now this itself is creating a series. Actually, whenever you are operating or whenever you are trying to do anything with a data frame, the subset will also be a data frame or series most of the times. Let us check that. I am assigning this to a variable. Data type is equal to our data frame dot d type, that is the attribute. Then let us check type of data types. Data type. You have to run this cell first, and then again. So it is pandas.core.series.series. This is a panda series object. So this is creating an operation on a data frame, is again creating a series. Series itself is a data frame of length of having only one column. Then you can print information about your data with info. So it is a data frame with 4017 entries with 5 columns, and each column day, data type, and mean gauge. Every day you have values. There are no null, there are so many values, 4017, but whereas discharge observations are not there for entire all rows. Some rows, some 24 plus 17, some 40 odd values are missing. Discharge values are missing, and you will find NaN value in those places. Now how to handle the missing data we will see. So there are 2 float type data types and 3 object or string type. Then we can also see some basic statistics of numerical data. So it will only take numerical data, which are 2 float column, mean gauge and discharge in QMax, mean gauge in meters. So there are 4017 entries in gauge, whereas if I discharge there are only 3976 entries. Then the value of the mean gauge, and then standard deviation, minimum value, minimum gauge for this entire period. The minimum gauge was around 2.56, whereas the maximum, unfortunately, it is giving a value of with reference to the mean sea level. So but still you can see that 25% values are within 2.97, 50% values 3.24. The variation of the gauge value you can see. Similarly, the discharge, the maximum discharge is 3883, whereas the minimum discharge is 321. Mean discharge is 213. So the input file, the CSV file, is not a validated data set as such. There may be some mistakes, but we are our purpose is reading the data into data frame. But it looks reasonable. The statistics are also they are very reasonable. Then these are various ways to check your data. We have seen how to read the data. Now we will see how to convert this data let us convert this data into an Excel file and save it. Yeah, one more thing is one more attribute, not that we are not aware of the columns, but this way you can also check columns, which will be printed as a list of column headers. Again, this has created some data type, I think a series has been created. No, a different different object has been created. Index, a specific type of object which stores index. Now you can also check the values. The same thing you will get. An array. Now let us check this type. It is a NumPy array. It is actually, when we deal with NumPy, we will be seeing the arrays. So when you are getting from the attribute of columns, when you are getting the values, it is stored in a NumPy array. Then quickly coming to the writing of data to a file. Now our data frame name is gauge underscore discharge dot data. Let us see the functions which are available with tab completion. You should be able to find read, not read but write to. Yeah, you can just as we have read underscore star asterisk functions to read data, you have to underscore star, that is various formats. You can write your data to various formats. I am selecting Excel. Let me also check the help option quickly. So it is a method to write a single object to an Excel object. Our object is data frame object excel.xlsx file. It is only necessary to specify a target file name. It is enough to specify, it is enough if you provide a name, and there are other parameters given the default values. Let us write into an Excel file. You provide the name gauge discharge data dot Excel sx. No module named open by Excel. I think for writing, for dealing with Excel files, we need to have this module. Let us try to import if it is already part of Anaconda distribution. No, there is no module named OpenPyXL in the entire thing. Now let us quickly check the installed packages in our environment. OpenPy. As you can see, this package is not installed, a Python library to read or write XLSX files. So we can click it. It is good that we are able to demonstrate at least one package installation through Navigator. You can click on apply. Therefore, this package will be installed in your environment Python _WRM. It may take some time. It is actually not a big thing because we already have a CSV file. You can convert it into, you can open it as an Excel file, but here the purpose is demonstration. In case if you are getting a data frame, if your data is in the form of data frame and you have modified it, you have done some modifications to your data frame, and then you want to convert it into into a Excel file. By modifications we mean adding of one additional data, one additional column, or some making use of existing columns. You can create a new column by operating some methods, and then you can write the modified data set into a new file. In that cases it will be useful if your data is voluminous. So it is still installing the package open PyExcel. Yeah, now it is done, which is marked by this tick mark. Now let us try to import open PyExcel. Now it is not throwing any error. Now we can even write our data into an Excel file. So now it has written the data into the Excel file. We can check where the data has been created, where the file has been created. It must be in our in the folder where we are operating, which is in the notebooks folder, because you can check the name of the data of the file, gd_data. You can open and see. So you have an Excel file having these 5 columns, and also you have an additional column of index starting from 0 all the way up to 4016. In case you want to you don't want this index in your file, you can do that by passing a parameter index is equal to false. Default parameter is default value is true, and you can overwrite with this. So it will again overwrite the file. Check the file again. As you can see that there is no index column now. So you can explore the other parameters of the of these functions, reading of files and writing of files from data to data frame and from data frame to create a new file. I am concluding this session here, as covering all aspects of pandas within one session will make it very lengthy. We will make it in two parts. In the second part on working with pandas, we will see more important aspects of subsetting of data frame, creation of new columns, plotting of data, joining of tables, etc. That we will cover during the second part on working with pandas. So, in the first part, we have seen introduction to pandas, and we have seen how to create panda data structures, namely data frame and series from scratch, and how to create a data frame by reading data from a CSV file, and also how to write the data from a data frame to an Excel or CSV format file. Thank you.